real slow. Just one tool at a time. There's no need to rush. Speed comes with time. It's all about experience, and you rather just take your time, do it right the first time, and you want it done fast, or you want it done right, and that's an important thing with setups. Is if you do it right, you'll gain the speed later on when everything's rocking and rolling. You can just run, but if you crash the machine or you mess something up, and it just slows everybody down. So now you've opened the door. You measure your OD. Supposed to be at 432. Put the mic on it. Bring it close to 4 and change. Then you can come down to 432, 431. Everything else looks pretty good. The other thing you want to check is your distance coming out. 500. That threader is going to come back to 495. So that's an important thing to do also whenever you have a threader or any type of tools touching the face. Make sure the cut's right and that we didn't run into any issues there. Okay, so now we're going to test the next tool, tool number 5. Same thing, nice and slow. Come down, comes down to x.0842, z.01. Now I'm going to proceed. It's going to come into like 499, which is 1 thou right against the wall. So it's kind of scary when that happens, but you just got to be on it and stay in control and do it nice and slow. Okay, so now I'm going to turn single block off. I'm going to speed it up. I'm going to turn the coolant on. I'm going to listen, feel, pay attention to what's going on. So now let's cut our thread release. So we'll put a nice little notch in the back so when the threader comes through, it has a little relief so it has, when it's picking the chips won't back up as much in the back. So now, tool number 9, same thing. Slow down the spindle, turn the coolant off, turn is engaged towards the part. We're going to hit single block, we're going to speed it up a little bit. This one should stop at 10 thousandths right in front of the face. It did that. Its X position is 0.583. So out here is like 866. So you look at that and go, does that make sense? You know, is it 200 or 300 thousandths lower? And with time and experience, you'd be able to go, yeah, if it was all the way up here, if it was down below, if it was out, you know, in a different position out in the front, that would be one of your trouble signs that, hey, something's wrong and it's not working. So now we're going to hit cycle start. It's going to come all the way into 490 and then it should stop. So it did that. I'm going to hit single block, coolant on, same thing. So listen, feel, look, and I think after this tool we're done with this segment of the video. Alright, so tool 9 has just stopped. So we look, we're going to blow the part off. We're going to see that the face groover's there. It looks good. It looks like our face grooving tool is still here. Very important with face groovers, it's easy to lose them. Have them chipped because they're so small. Now we're going to go to tool number 7. Same process. Turn the speed down, turn the coolant off, cycle start. Wait for the turret to move towards the spindle. Hit single block. It's going to come down to 1 inch. It's going to stop. Now it's going to move to position of z.300 thousandths in front of the part, which will be right out here, roughly, give or take a couple thou. And when that happens, we'll hit cycle start again. And then it'll come down to an X dimension of 0.438. And after that, so now it's at 438. So now the next time I hit the button, this tool is going to slide all the way back to this wall and then come out and come back up, and this is what's called a can cycle. So once we start this, we can't, when you hit cycle start, in the beginning of a G32, the G32 will finish or it'll register the feed hold button. So if something's wrong and you hit cycle start, this tool is going to go Z minus whatever, then it'll stop, even if you hit the hold button. So you're unable to hit the feed hold in the middle of a can cycle, period. So you need to make sure that you know what's going to happen with the tool, your X's and Z's are right in the program, and that your tool looks like it's in the right position. We also took the time to measure the distance from the front of the tool to the back of the tool, so the threader had enough time and space to travel as far as it needs to go. Because if it runs into something, it's going to crash the machine, it's going to break the tool, and it's just not good. So this is one of the scariest tools you'll run. Another thing we like to do with threading tools that I like to do that I just learned like a year or two ago, somebody suggested to me, is, well, I'm going to show you. Okay, so we're going to take the work shift and we're going to slide the work shift out 3 inches. So we're going to come all the way out here. Can you double check to make sure you can see what I'm doing next? Yeah. Because it's a little further from the turret. Okay, so now we're coming out. We're going to run the same tool again. And the tool's going to be cutting air to give you guys a good visual on what's happening when a can cycle runs. Okay. So now it's coming in. So there's your can cycle. 1, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, so basically all it did is it just made a little box. Came in, came out, came in, came out, came in, came out. A little box. If there's anything other than that little box going on, where it stops at the end, it jumps up and down, or just, goes too far, it needs to be a consistent box, and that's your threading can cycle. Because it comes in, starts in one position, and it repeats. So it just does that little box, and it's very important that if you see anything different than that little box happen, that you take a look at the program. It means there's a number wrong, there's a digit misplaced, somebody put a decimal wrong. These things happen, especially if it's a new program and we've had to, do everything from hand, or sometimes Gibbs does some weird things. So now I'm going to go back into the tool. I'm going to slide the work shift back 3 inches. So now the turret is in the regular position. I'm going to go edit program reset, and 7, cursor down. Okay, coming in slow, single block. Okay, down to 438. We're going to close the door. We're going to leave it on slow, turn the coolant on. Now again, it's just doing that little box. 1, 2, 3, 4, 1, 2, 3, 4. Down, in, up, back. Down, in. Just like that. Same thing, so you want to listen, you want to keep your finger near the feed hold button if you hear something bad, or if it sounds like it's laboring too much, or it sounds like it's crunchy, like maybe the insert broke or something happened. Okay, so now we're going to repeat tool number 5, and it says N55. So anytime you see a double digit, with the exception of the mills, lathe mills, because the lathe mills have 24 stations, but because it's a single digit, it's an N5, which is N55, we're going to repeat tool number 5. So we're just going to speed this up a little bit to the N55. Now the N55 is just doing the finished pass on the thread release. So it comes down here, it puts a little chamfer, comes here, does a little chamfer, makes sure that thread relief is nice and smooth, and it knocks the burr off the back of the thread. That's why if you see that the burr, if you look at your thread relief and you see lines in it, it's because the threading tool has gone all the way back, and that's where the lines come in. Okay, same thing with 77, it should repeat. So it's tool number 7, but we call it 77 because we're running it a second time. Okay, now we're to the final part-off tool. Part-off tool comes out, single block, close, boom, boom, boom. Okay, that position is X.975, Z.100. Cycle start, it's going to slide in, make sure it's got clearance off the part. Comes in, single block off, pull it on, slow it down, listen, feel, make sure everything, sounds good, feels good. Any problems, hit cycle start. And there's our part. Looks pretty good. We're going to go over all the dimensions to make sure we don't have any burrs.